All right, so now that we have fully developed the concept of factoring quadratic equations or quadratic expressions, now we want to look at solving quadratics. And solving a quadratic, like solving any other equation, always means find the value of the variable. And we're going to start, there's more than one way to do this, but we're going to start with the zero product property. That's what ZPP stands for, zero product property. And the zero product property just says that if you have two things multiplied together and they equal zero, so if A times B equals zero, then either A equals zero, because zero times anything is zero, or B equals zero, because zero times anything equals zero, or A and B equals zero. That's all it says. So we can use this because if you look at this A and B, it looks a little bit like a factored quadratic. So instead of solving quadratic expressions, we're now going to solve quadratic equations using the zero product property. And the whole goal here is to find out what does x equal, or what does the variable equal, depending on what letter you use for it. So let's do an example and I'll explain as I go. Solve the quadratic equation x minus 5 times x plus 3. So I took a little bit of a shortcut. Oh, equals 0, sorry. I took a little bit of a shortcut. I already factored this problem. I didn't start with a polynomial that had to be factored, but whatever the polynomial was, this is the factored form, and you should recognize that pretty well by now. Once you have the factored form in a polynomial, you can use the zero product property, which I also call chicken feet. And chicken feet is just a way to show that there's more than one answer. So when I say chicken feet, I'm talking about the zero product property. And I tend to set it up where I factor the problem equal to 0, and then I set chicken feet across the equal sign. So using the zero product property which says that if two things together, two products, or if two factors multiplied together equals 0, then one factor equals 0, or the second factor equals 0, or they both equal 0. So we want to use that to solve for the value of x. What we're saying is that if this factor equals 0, then it's enough for the entire side of this equation to equal 0. 0 times whatever that is would equal 0. So if I find the x that makes this factor equal 0, I will have found a solution to this equation, or to this quadratic equation more specifically. So that means I need x minus 5, the whole thing, to be equal to 0. And by the very same logic, if this one equals 0, then it's sufficient for the whole side to equal 0, and I will have a solution to the equation. So x plus 3, the whole thing together, equals 0. So all I've done is taken the first factor, set up an equation where it's equal to 0, because that's what I want to find, and then take the second factor and set up an equation where it's equal to 0, because I want to discover which x would make it equal 0. And now it's just an equation I can solve. X equals 5 and x equals negative 3. Now, probably I didn't need to write the equation, but this is the algorithm I want you to use, at least while you're developing this concept or this skill. So x minus 5 equals 0. What would x have to be for that to be true? Obviously a positive 5. X plus 3 equals 0. What would x have to be? Obviously a negative 3. Now let's test these. Let's check and see if this is true. So we're going to check the same way we always do. I'm going to plug in first 5. So I'm going to say x minus 5. Well, I don't need to write the whole thing out. 5 minus 5 times 5 plus 3 equals 0. And I'm checking, so I'm going to put a question mark because I don't really know if it's true, if I have the right answer yet. So 5 take away 5 is 0 times 5 plus 3 is 8 equals 0. 0 times 8, 0 equals 0. That is a true statement. And so x equals 5 is a solution to this polynomial, to this quadratic. How about the next one? Let's take negative 3 minus 5 times negative 3 plus 3 equals 0. Again, I don't know. Negative 3 minus 5 is negative 8 times negative 3 plus 3 is 0. Does that equal 0? Well, negative 8 times 0 definitely equals 0. 0 equals 0 is a true statement. And so I have actually found the two solutions that make this polynomial equal 0. I found the two x values. I have solved for the x values that make this sentence true. So now that you've seen a problem kind of worked out, let's talk a little bit more specifically. In order to use the zero product property, you have to have two factors, whatever they are, and they have to be equal to 0. It's super important that this equals 0. If you don't have a 0 on the other side of the equation, you're not going to get good answers. And that sort of makes sense when you think about it, because if I'm looking for two things multiplied together equals 0, then I can find a specific value like I did here for each x. But if I had something like x minus 3 and x plus 2 equals 12, well, I could have any combination. I could have, this could be a 3 times 4, which means x would be 1 and x could be 2. It doesn't give us anything unique, and there are too many combinations that could make this a true statement. So we really have to have it be equal to 0. The zero product property requires that you have an A and a B, something A, something B, and they have to equal 0. If they don't equal 0, you can't use the zero product property. Also, whenever you solve a quadratic, because they're second degree polynomials, right? Second degree polynomials, you can come up with two answers. You won't get three solutions. You can only get two or less. So sometimes there's nothing that solves it. Sometimes there'll only be one, or there can be two, and hence the chicken feet, just to remind you that there are two things. You're looking for the place where A equals 0, where A is some expression, or B equals 0, where B is some expression. Okay, let's do another example. Probably a good time at this stage of the game. All right, so this time we're going to take x squared plus 6x equals 0. So this is a quadratic equation. It's a quadratic expression on one side and 0 on the other side, so I can use the zero product property if I can factor this polynomial. And in fact, I can. They both divide by x, so I'm going to pull the x out front. X squared divided by x is x, and 6x divided by x is 6. That all equals 0, so now I can chicken feed. Well, in the first factor, x equals 0, we're done. That's one of the solutions. If x equals 0, then this whole side will equal 0. And the other solution would be x plus 6 equals 0. So x equals negative 6. All right, so let's do another example. 3x squared minus 10x equals 8. So I'm asked to solve this equation. Solve the equation means to figure out what does x equal, what variable, what number could I plug in for both of these x's that would give me a true statement, or that would say that this sentence is true, that the left side is equal to the right side. This would be a very difficult problem to solve by hand, trying to figure out by guessing, basically. Try a 2, That wouldn't work. Try 3. That wouldn't work. Try 4. That wouldn't work. What about a fraction? 1/2. I don't even want to think about how long I would have to spend guessing and then checking to see if I'm right. On top of that, remember, this is a second degree polynomial, which means I could have 2 right answers. So once I finally guessed one of them and checked it until I knew I was right, I would still have to guess again. That's crazy. So the zero product property is a super simple way to do it. And we should look at this. I have 3x squared minus 10x equals 8. Zero product property requires that I have factors on one side and that I have 0 on the other side. And when you work with this one, you always want to solve for 0 first and then factor. So first I'm going to subtract 8 from both sides. And now I have an expression, a polynomial expression that's equal to 0, and then I'm going to factor my expression if possible. If it's not possible, I won't be able to solve it using the zero product property. I'll have to wait until I have another technique. But the zero product property, if I can factor, is very easy to use. So this has a leading coefficient. It's a quadratic trinomial with a leading coefficient. So I'm going to multiply 3 times -8. Gives me -24. So now I want 2 numbers that multiply to give me -24, but add to give me 10. So 6 and 4 seems like a likely candidate, but 6 and 4 don't work because one of them has to be negative. If -6 and +4, only one is negative. -6 and +4 would give me a -2, or +6 and -4 would give me a +2. So 6 and 4 don't work. I think the next best chance is using 12 and not 12 and 10, 12 and 2. I guess I never wrote the wrong thing down. I just thought it in my head. So 12 times 2 is 24. Good. One of them has to be negative, and in order to get a -10, it would be the 12 that would have to be negative. Now remember, this is magic numbers, which means I have to divide by that 3 again. I'm going to reduce this one. So I get -4 and 2/3. So now when I write this as my factors, remember this is an x, put my x's in here. So I can rewrite my x minus 4 and 3x plus 2 equals 0. Zero product property, or chicken feet, says x minus 4 equals 0. I'm looking for this whole thing. What x would make this whole factor equal 0? And then what x, oh, I wrote that wrong here, 3x plus 2. And then what x would make this factor equal to 0? So I'm going to write 3x plus 2 equals 0. So I can solve for the x that makes this whole factor equal 0. Well, in the first case, x would equal 4. And in the second case, 3x equals -2, and then x equals -2/3. There we go. There was a fraction solution for this polynomial. I would have never guessed 2/3, or I might have eventually, but I wouldn't have done it quick enough for my liking. So I think I'm going to go ahead and check these two back in the original. So I have 3x squared minus 10x equals 8. If I plug in 4, 3 times 4 squared minus 10 times 4 equals 8. 4 squared is 16 times 3, 48, minus 10 times 4 is 40, equal 8. And I probably should have a question mark here. 48 minus 48 equals 8. That's a true statement. So 4 is a solution to this equation. Now let's check -2/3. 3 times -2/3 squared minus 10 times -2/3 equals 8. We're not sure if that's true. So we've got 3 times, well, the numerator squared is 4. The denominator squared is 9, minus 10 times, well, multiply across the fractions. That'd be a 10 over 1. A negative and a negative is a positive. 10 times 2 is 20 over 3. 3 times 1 equals 8. So I can cancel a 3 with this denominator, and I get 4 thirds plus 20 thirds equals 8. Running out of room here. And so I have 24 divided by 3 equals 8. 8 equals 8. That is indeed the solution, the other solution to this equation. So x in this equation, the only x's that make this sentence true are 4 and negative 2/3. I'm okay that I have two answers for my x, because when I have a second degree polynomial, I can possibly get 2 or 1 or 0 answers. So it is possible to get two answers for a quadratic equation. So let's just take a second to review what we've done. We're going to start solving quadratic equations. The first step we're going to learn, or the first method we're going to learn, is using the zero product property. The zero product property says if you have two factors multiplied together and together multiplied they equal 0, then either A equals 0 or B equals 0 or A and B equals 0. And the way we set that up in a quadratic is first we start with any quadratic equation. We first solve moving everything to one side so that you have a 0 on one side. Then we factor what am I trying to say? We factor the polynomial on the side that's not 0, and then we set each factor in turn equal to 0. So I decide, well, if this side equals 0, that means A has to be 0. What x would make A equal 0? And it means that B has to be 0. What x would make B equal 0? And to find out, I set up an equation with A and B and solve.